Today we're going to learn about the analysis of exponential functions graphs. Fill out the chart and graph y equal 2 to the x. Check out with the calculator. So if x is 4, and we have 2 to the 4th, which is 16. That's our first point. If x is 3, 2 to the 3rd is 2 times 2 times 2, which would be 8. If x is 2, we would have 2 to the 2nd, which is 4. If x is 1, we have 2 to the 1, which is 2. If x is 0, 2 to the 0 is 1. Remember, any number to the 0 power except for 0 itself is 1. Now, negative exponents are tricky. So 2 to the negative 1, if you raise a number to a negative power, the way we define this is that it's the reciprocal of that number to the positive power. So it'll be 2 to the 1. We don't have to write the 1 here because 2 to the 1 is 2. So for example, 2 to the negative 2, that just means that's short for the reciprocal of 2 squared. So a negative power just literally means reciprocal. Okay? That means a reciprocal of 2 squared, which is a quarter. So you get the idea. You can also do this on the calculator just to check. Negative power. So an exponential function is one where the exponent itself is a variable, right? Not the base. So you've seen y equal to x squared. That is where the base was a variable. Here the exponent is a variable. So if we plot these points, you're going to get something that looks like this. And I'll show you in a moment how to use the calculator to get this. So 416 is not on this graph because that would be too high. But you could see 2, 4 is over here. 1, 2, 0, 1, negative 1, a half. And the fractions are pretty difficult to see. So on the calculator, to do that, we go to here and the power function. And we need 2 here on the base, and we need x in the power. Enter, and there you go. And if you want to actually see the points, you can go to table, split screen, and there's your table. So you can look and see when x is negative 1, y is a half. That's what we got. Negative 1, y is a half. When x is negative 2, y is a quarter, or 0.25. Okay, so here you can see all the points and look how quickly this grows. By the time x gets to 9, it's already up to 512. So you might have heard of quantities growing exponentially. Viruses spread exponentially, for example. Tumors grow exponentially. So in this case, if you notice, quantity keeps doubling. So you start with a 1, and then if you double that, you get 2. If you double that, you get 4. If you double that, you get 8, and so on. So when you're doubling a quantity over and over again, that's called exponential growth. Okay. And so that's what it looks like. It's quite interesting and quite different from the other functions we've had in a bunch of ways, and we'll see that in a minute. But for now, let's look at some graphs. So once again, this is the mother function, y equal 2 to the x. If you look at these, they have a leading coefficient. The base could change from 2 to whatever number you want, as long as it's not 1 or 0. Okay, so this is the equation we just looked at. 1 times 2 to the x, that's 2 to the x. So that's your basic graph. This one, you can guess. Think about what the x-intercept would be. So remember x-intercept? I'm sorry, the y-intercept. The y-intercept you get by letting x equal to 0. If x is 0, we have 4 to the 0, which is 1. And 1 times 3 is 3. So when x is 1, y is 3. When x is 0, y is 3. Excuse me, I'm getting tired. So the graph basically stretches vertically because your leading coefficient is greater than 1. And also, this is your y-intercept. That's right. And of course, instead of doubling here, what are you doing? 4 to the 1, 4 squared, 4 to the third. You're tripling. Sorry, you're quadrupling. You're quadrupling the quantity you start with, right? So if when x is 1, you have the quantity is 4. But when x is 2, the quantity is 16. Right? So from one point to the next, you're really quadrupling, you're multiplying by 4. So this is going to grow up very fast, much faster. Okay. This one is 2.5 times 3 to the x. Again, once you notice that when x is 0, y would be 2.5. So that's the y-intercept, but the basic shape is still the same. And notice that the graph looks as if it's touching the x-axis, but it's not, because there are no x-intercepts, because y can never be 0 here. A number to a power could never be 0. So there are no x-intercepts, and the graph is getting closer and closer and closer to the x-axis, but it never quite gets there. So it's like when you're looking at the horizon and you see as if it looks as if the earth is touching the sky, but it really isn't. So it's the same concept here. It looks as if this is touching the x-axis, but it really isn't. So let's look at some patterns. So the general formula for this is y equal a times b to the x. And a, if you notice in each of these cases, 1, 3, 2.5, a represents the y-intercept. But you can find that by setting x equal to 0. The larger b is, so here's 2, here's 3, here's 4, the faster the graph is increasing. As x gets more and more negative, so as x goes to negative infinity, the graph gets closer and closer to the x-axis. There are no x-intercepts. And notice that it's always increasing. Remember, you're reading this from left to right, so the graph is always increasing. When it's of this form, everything's positive. Okay. Let me just check and make sure that I didn't miss anything. Okay. Now let's look at an example where the base is a number between 0 and 1, such as 0.2. So if you keep multiplying by 0.2, you're really decreasing the quantity, right? So for example, here, when x is 1, wow. So if you just look at a couple of values just to get the idea of what's happening. Okay, let's look at x and y. And if our x is 1, let's see if this works. No. If x is 1 and I'm substituting it in there, 0.2 to the 1 is 0.2 times 3. It's going to be 0.6, right? If x is 2, though, what's 0.2 squared is 0.04, and 0.04 times 3 is 0.12. So notice that the quantity decreased, right? 0.6, from 0.6 to 0.12, that's a decrease. Okay. And so what we're noticing here is that if b, the base, is between 0 and 1, the graph is going to be decreasing. So this is the opposite of growth. This is called decay. And many things in nature decay exponentially. You'll learn about this in chemistry more specifically. Also, as x increases, in this case, the graph gets closer and closer to the x-axis. Because the bigger the x is, the smaller the y is going to be. This is just going to keep getting smaller and smaller. So the y values are going to get closer and closer to 0. Okay. My graph is a bit naked here. Let's put our x and y, label our axes. We know better. Okay. Now, we keep saying that the graph gets closer and closer to the x-axis. So the x-axis has a name in this case. It's called a horizontal asymptote. It's a horizontal line that a graph is getting closer and closer to as x increases to infinity or as it decreases to negative infinity. So it's basically just a line that the graph gets closer and closer to. Okay, so keep that in mind. So let's try to sketch this without a calculator. So now we know that if x is 0, y is 1.5. So that would be my y-intercept. And we're doubling quantity here, so the graph is going to get bigger and bigger. Okay, this is a rough sketch. We can also do this on the calculator. Now, this is saying from -4 to 4. So technically from here to here. Okay. But you could do that on the calculator. And this one, since b is between 0 and 1, this is going to be decay. Y-intercept is 3 here, so it's x equal to 0 will make y equal to 3. So the graph is gonna look something like that. Okay. And in either case, that's supposed to be 3. In either case, the x-axis is your asymptote. So here you're going from -4 to 4, so make sure you end and stop at the right place. Okay. And I think that's all I'd like to talk about. So just in summary, this is called an exponential function if b is greater than 0 and not equal to 1, because otherwise it would be trivial. It wouldn't be exponential. This is getting you ready for later on, but we can have it here. A is called the initial amount and B is called the growth factor. Then we have the horizontal asymptote, which is y equal to 0, the x-axis. We know that if the base is between 0 and 1, the graph is decreasing. That's called exponential decay. But if b is bigger than 1, the graph is increasing. That's exponential growth. And there are no x-intercepts, and 8 is the y-intercept. And that concludes this lesson.